All right, today we're talking about the directrix and the focus of a quadratic equation. Now, in all of these, we're going to have a vertex at 0, 0. And we are going to have specific forms for the equation x squared equals 4py, or y squared equals 4px. Now I know this one is very unusual because we don't normally have y squared, we usually have just y. And this one, the y isn't by itself first, it's got stuff multiplied and the x is squared. So when you have it in this form, it opens up when p is greater than 0. Its focus is at 0p. It has a directrix, which is a line, y equals negative p, and we'll talk about that directrix in a bit. The axis of symmetry is a vertical line, and it has the equation x equals 0. If p is less than 0 or negative, then it opens down, has the same focus of 0p, same directrix of y equals negative p, and the same vertical axis of symmetry, x equals 0. On the other hand, if your equation is y squared equals 4px, if p is greater than 0, positive, it has a vertex that at 0, 0, but it opens to the right. Focus of p0, directrix of x equals negative p. It has a horizontal axis of symmetry at y equals 0. If p is less than 0, it opens to the left. Now normally we have parabolas open either up or down. Well, these are opening to the left or right or left. P0 is your focus. X equals negative p is your directrix, and it has a horizontal axis of symmetry, y equals 0. So let's focus in on this, and I'll just do that so we can just pay attention to this one. We're asked to find the focus and directrix of the parabola. Well, to start here, we have the equation x squared equals 4py. Now, if we go back a little, x squared equals 4py, x squared equals negative 24y, x squared equals 4py. Now, if I look at these two, they're identical except for this part. So I'm going to set those two things equal to each other so I can find p. So if I divide by 4, I don't know why I put p on that side, p would equal negative 6. Now if we recall, we're asking for the focus and directrix. When you have a situation where it's x squared equals 4py, then your focus is 0p. It's in the y coordinate spot. The variable that's not raised to a power is the one you're using for focus and your directrix. So focus is going to be at 0p. The directrix is going to be y equals negative of p. Well, if p is negative 6, negative of that would be positive 6. And that's how you set it up. That's the focus and directrix. Now we'll see exactly what a focus and a directrix are when we graph them. And that's coming up after this slide. So here's our next example. Well, wait a minute. I don't have anything next to y, so that's understood to be a 1. So we know it's understood to be a 1 here. So if we say 4p equals 1, and we go to solve it, p must equal 1/4. So my focus Remember, this is still an x squared equals 4py, just like this last one. So the focus has 0p. P happens to be 1/4. The directrix here, let's see, y equals negative of p. And negative of 1/4 is negative 1/4. And there is your answer there. Let's look at the last one. Oh, hey, this one says 5y squared equals x. Well, I don't have the squared thing by itself. I have to get rid of that 5. Let me do that with a different color. Divide both sides by 5. Y squared. Trying to do too many things at once. Divide by 5. Y squared equals 1/5 x. Dividing by 5 is the same as multiplying by 1/5. So 4p has to equal 1/5. If I divide by 4, that's the same as times 1/4. So p ends up being 1/20th. Okay. Now, in this one, we're working with y squared equals 4px. All right, if that's the one I'm working with, remember, if it's y squared equals, then x is the one that's not raised to the power, so it's in the x coordinate spot for the focus, and x equals negative p for the directrix. So, focus. It's in the x coordinate spot, 1/20th, 0. And the directrix is going to be x equals negative, opposite sign of this, 1/20th. There are your directrix and focus for each of these problems. All right. Graphing. Identify the focus and directrix and the axis of symmetry of the parabola. All right, so first I'm going to plot those things that we talked about, directrix and focus. We know that this is 4p has to equal negative 12, so p, I'm going to divide by 4, negative 3. All right, and again, y squared, p0 is your director, as your focus. Because it's the one where x. So focus is at negative 3, 0. That's your focus. Just put a little f there. Your directrix is the line x equals negative 3. So let us put a line. I don't like that one, so I'm just going to use a dotted line. And let's make it obvious. And x equals positive 3. That should be a positive 3. I put a negative 3. X equals positive 3. And I'll fix that, so it's a positive 3. Sorry about that, folks. It's always negative of p, and if p is negative 3, then this is positive 3. That's our directrix. Now, we need some tables of value, or table of values. All right. Now, when you think about it, it would be easier to solve this if it weren't in this form. So I'm going to bring that down here. Y squared equals negative 12x. Okay. This is going to be much easier to do if we have x by itself instead of y by itself in this case. So I'm going to divide by negative 12. So I get x equals y squared over negative 12. That's what I'm going to use to plug values in to get answers out. I could always plug in values of x and get answers for y. The problem is y is squared, and so that means I'd have to square root both sides, and that is very messy. So it's much easier to square y and divide it by negative 12 to get answers for x. So that is what I'm going to do. I'll just bring that up here so we can see it a little better. And I'm going to plug in values for y and get answers for x. That's actually harder than you think because you are so ingrained to plug in x and get y that it's easy to make that mistake and go the reverse. So if I put 0 in here, 0 for y, that's going to make that 0. That one's not bad. If I try to put 1 in there, am I going to get an easy answer to graph? Heck no. It's going to be very difficult to graph. Even, say, 2. 2 squared is 4. 4 divided by negative 12 is a negative 1/3. That's tough enough. So, of course, negative 2 will give me negative 1/3. And I am not going to be anywhere near the room I need to write all this. So I'm going to erase that and start again, giving myself a little more room. 0, 0. And we said, remember, you're putting in for y. So 2 and negative 2 give me negative 1/3. So I'm going to have much larger numbers to work with than 2 so that I can get something that's going to be reasonable. So let's try 6 and negative 6. 6 squared is 36 divided by negative 12. 36 divided by negative 12 is negative 3. All right. I could go as far as 12, but that might be tricky to work with. Let's do 12 and negative 12. We know that 12 squared divided by negative 12, it's going to be a negative 12. And that's going to be a little bit off my graph, but these are enough points for me to graph 0, 0. In fact, I think I'll use blue instead, show up a little better. And remember, you're plugging in now you're plotting points. So negative 3, positive 1, 2, 3, 4, 5, 6, negative 3, negative 1, 2, 3, 4, 5, 6. All right. Negative 1/3, 2, and negative 2. And then that's enough, but we can go out. Now it goes out to about here for 12, 11, 12. So negative 12, let's see. I need to go up to the right 2. So about there and about maybe there down here, roughly. Now I'm just approximating where to put this down here. All right, so here's my graph. That would be the parabola y squared equals negative 12x. All right. Directrix, focus, and then I'll draw in the axis of symmetry. Let's make that line a little thinner, and let's make it red to show up. This is the axis of symmetry. It's a line that cuts the vertex in half, and what's on one side is on the other. That's why it has to be a horizontal line. All right, now that we've done that one, let's put this under here. Now we're going to approach this one. X squared equals 6y. Well, first of all, table of values. I don't know if I've got that far enough over. I don't think so. I have to move it a little bit. All right. Let's see. Focus. 4p rather equals 6. So p is going to be 3 halves. 6 over 4 is 3 halves, or 1.5. So this one, the focus is 0, 3 halves. So up 1.5. There's our focus. And our directrix is going to be, let's call it this. No, this. It's going to be a horizontal line at -1.5. There's our directrix. All right. Now we have to plot some points. We're going to have to get this rearranged, so I'm going to write it as y equals x squared over 6. Now at least this time it's going to be a little easier to come up with values because you're not dividing by 12, you're only dividing by 6. We know if we plug in x, because x squared is a lot easier to plug in and solve for y, 0, 0. I could do 1, but that's going to give me 1/6, so I'm going to do 2. 2 squared is 4, so that's 2/3. -2, 2/3. All right, how about 3 and -3? 3 squared is 9. 9 over 3 would be 1.5, or 3 halves. I should really change this to smaller writing. All right. How about 6 and -6? That's going to give me 6. Because 6 squared is 36, divided by 6 will be 6. And that's enough for me to plot these points. All right. So, 0, 0. No, I think I need a different color. 2, 2/3. -2, 2/3. It's not quite up right, but 3, 1.5. -3, 1.5. 6, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And there's my graph. All right. So graphing these is a little tricky. It helps to rewrite it in the variable to the single power by itself. Plug in the squared variable. Much easier to do. Now, directrix and focus. What does that have to do with anything? Okay. It's important to know where that all comes from and why. Let's put it in a different color so that it shows up. For directrix and focus, the distance from the focus to any one point on the line is equal to the distance from that point on the line and then directly to. Now, when you try to measure the distance from a point on a curve, from a point on a curve to a line, you have to draw it so that it ends up being perpendicular. So the distance from here to here has to be a perpendicular intersection. So that distance is going to be the same as the distance from this point focus to the point on the line. Now I could draw this to here. The distance from here to here is going to be the same as the distance from here to that intersection, making a 90-degree angle. It doesn't matter where I draw it. I could draw it to here. This distance and that distance are going to be the same. That's one of the things that it comes up with for what the purpose of a directrix and focus are. The other purpose for directrix and focus has to do with, for example, a satellite dish. You've all seen a satellite dish, and you've seen that knob that's out in front of the satellite dish. Well, that satellite dish knob is at the focus. So when rays of whatever, I'm trying to think of, but when radio waves, television waves, whatever, come in and they hit a point, they're going to go to the focus. So when they come in, they bounce off and go right at that focal point. And that's one of the big keys as to an actual use of a directrix and focus. Another example of that, have you ever seen a solar hot dog cooker? It's in a parabola shape in a trough, and then there's a wire or something going through that you skewer the hot dog on. Well, that wire happens to be at the focal point, and you've lined it with foil so that it comes in and hits and goes there. The same thing happens with all of those solar arrays that they make to do heat production, and they'll put those out in the desert somewhere usually, and all the mirrors go to that focal point. They're all aimed at that focal point, and they're parabolic mirrors. They're not flat, they're slightly curved, and they're all focused at that point. All right, so that's enough of real world. Why do we have these? Now let's go from a directrix or focus to the equation. So if I am trying to rewrite each of these, and let's focus on one thing at a time here. If I'm trying to rewrite this into the form of a directrix focus parabola, I know that it says y equals -1 is the directrix, then y is the variable that's by itself. So that's in the x squared equals 4py equation type, because y equals is the directrix. Remember, y equals -p in a directrix, so therefore positive p must be the opposite of this, +1. So the equation x squared equals 4 times 1, 4y is the equation here. Same kind of thing here, but the difference here, it's y squared equals 4px. If x equals -p, then positive p must be 2. X squared. Y squared equals 4 times 2, 8x. That's how you set it up. Now let's look at a focus problem. All right. In this one, the focus is in the x coordinate spot, so it has to be x to the first, y equals 4px. If this is p, 3/2, then y squared equals 4 times 3/2 x. Y squared equals, now when I multiply here, the 2 reduces with the 4, so it ends up as 6x. In the next example, it's in the y coordinate spot, so we're using that formula, x squared equals 4py. So therefore, and p is 4, so x squared equals 4 times 4, 16x. Finally, in this one, p is negative 3/4, and we have to use, let's see, that's in the y, so x squared equals 4py. Negative 3/4 times 4 is going to be negative 3, so x squared equals negative 3y. And that's how you do it. Your homework will be in Google Classroom. Have a great day.